Hi there, this is a GCSE Mathematics transformations question, and we've got a reflection, and then we've also got to try and find a single transformation to get A onto B. So if we start with part A, reflect triangle A in the line x equals 3. The first thing we're going to need to do is identify the line x equals 3. So in order to do that, it's going to select a line. I'm actually going to make it red as well. So x equals 3. Well, you should notice that x equals 3 here, and actually x equals 3 here, and everywhere along this vertical line here will have an x coordinate of 3. So that makes that dotted red line the line x equals 3. Now we're going to have to reflect A in that. So you'll notice that this point here is 2 squares away from the line if you go perpendicular to the line, and we end up over here. So I've gone 2 squares the opposite side of our line of reflection. So that's our first point there. If I do this same thing and plot a line from this point, which goes 2 squares across to get to the line of reflection, and then I go 2 more, and I've got my second point, and then finally the last one I need to find, this point here. Now I need to go 3 squares across in order to get to the line of reflection, so I go 3 more the other side, and that gives me my final corner, which is here. So that means that we can now put our reflected shape in by joining up those 3. And it says to label the shape or the image C. So we do that there. You get one of the marks for having a reflection and the other mark for doing it correctly in the line x equals 3. The next part says describe fully the single transformation which will map triangle A onto triangle B. The first thing to spot is it's not going to be a rotation, because if you look at, if I just trace around shape A, and you could do this using a piece of tracing paper and probably do it more accurately than I have. If you turn that around, you'll notice that it's a different orientation to that one. So it's not going to be a rotation, and actually it turns out to be a reflection again. So I'm just going to get myself a red dotted line again, and we'll have a look at how we can identify the line of reflection. It might help in some cases if you actually turn your piece of paper in front of you, should you have it in an exam, to try and get the line of reflection in a vertical direction. It tends to make more sense. What we'll see is that that turns out to be the line of reflection. One of the ways to spot that is just by naturally spotting that they're similar shapes and that they reflect in a diagonal line. The other way is to look at some of the coordinates. So that coordinate there is 3, 0, and that coordinate there is 0, 3. That coordinate there is 1, 3, and that coordinate there is 3, 1. What that means is that it appears that all the x coordinates and the y coordinates are swapping around, and that's a bit of a hint to tell you that the equation of this line here that we've found is y equals x. Because when you reflect in the line y equals x, it actually means that the x coordinates swap with the y coordinates. The reason this line is y equals x is that if you look at this point here, 1, 1, 2, 2, 3, 3, 4, 4, at every point on that line the x coordinate is equal to the y coordinate. What we need to make sure we do is write out our transformation in full. So it's a reflection, and that's where your first mark comes from, and then the second one is identifying it's in the line y equals x. Just for reference, if you had a horizontal line as a line of reflection, I hope you realise by now that a horizontal line, like this one here, if required, the equation of that line would be y equals 2, because everywhere on that line the y coordinate is 2.